Now let's look at the original equation symbolically. If S and D stand for the number of sane and demented people, the numbers of sane and demented people, then 0.20S and 0.10D, of course, are the transition numbers. Then what happens, what are the numbers going to be in the next, after a transition? Okay? S is going to lose 0.20S and gain 0.10D, so we're going to end up with a sane number that's S minus 0.20S plus 0.10D, which is 0.80S plus 0.10D, because S minus 0.20S is 0.80S. And similarly, D is going to be D minus 0.10D plus the 0.20D, D minus 0.10D plus 0.20S, not 0.20D. And the D minus 0.10D is 0.90D plus 0.20S. So that these will be our numbers after a transition. Now we could go to another transition. The transition numbers here would be 0.10 of the 0.90D plus 0.20S, 0.20 of the 0.80S plus the 0.10D. If we multiply these numbers out, turns out that we end up with polynomials in the 0.20 and the 0.10 and so forth. And that kind of leads us into some Chapter 10 topics that we're not going to talk about right here. Okay? But this leads us into considerations of geometric series and so forth, and we might make that connection later. Now, we see that the number of sane becomes 0.80S plus 0.10D. We're going to find it convenient to represent this calculation in terms of what we call a column, well, a row vector here, and a column vector here. This is called a row vector and a column vector. A row vector consists of numbers in a row. In this case, there are two numbers in the row. There could be 3, 4, 5, 6, any number. And a column consists of numbers in a column. Now S and D stand for the numbers of sane and demented. These will stand for the numbers in your column. And again, a column can be any length. A row can be any length. A column can be any length. If the row and the column have the same length, then we can multiply them, in the sense that we multiply the first number in the row by the first number in the column, and the second number in the row times the second number in the column. And if there are third and fourth and fifth and sixth numbers, we do the same thing with those. Third number of the row times the third number of the column, fourth number of the row times the fourth number of the column, and so on. And then we add up the results. Now, in this case, we just have first number times first number. That'll be 0.80 times S, and there's our 0.80S. And 0.10 times D, which comes out here. And we add them together. That's what we get when we multiply a row by a column. A single number. This is a single number. This is a number. This is a number. When we add them together, we get a single number. In general, if we have a row with numbers A and B and a column with numbers C and D, then the product of the row by the column is AC plus BD. First times first plus second times second. This is how we multiply rows by columns. Now, the convenient thing about rows and columns is we can stack rows on top of each other. And we could put columns next to each other if we wanted to. When we do either of these things, stack a bunch of rows of equal length, or put a bunch of columns side by side, columns of equal length side by side, and enclose them in brackets to indicate that we're talking rows and columns here, then we call this a matrix. So we'd have this matrix at 0.80, 0.10, 0.20, 0.90. This is a row, and this is a row, multiplied by SD, the column. Now both of these rows get multiplied by the column. If we multiply the first row by the column, we get just what we got before. First times first, second times second gives us 0.80s plus 0.10d. Then if we multiply the first number in the column by the first number in the row, go to the second row. Multiply the first number in the row by the first number in the column, second number in the row by the second number in the column. We get 0.20s plus 0.90d. Since the 0.80s plus the 0.10d came from the first row, we're going to put it in the first row of this matrix. Since the 0.20s plus 0.90d came from the second row, we'll put it in the second row here. Okay, so actually this is a column with just two numbers in it. The first row just consists of the number you get when you add these quantities, the second of the number you get when you add these quantities. If we continue the process, multiplying again, let's stop a minute and see what this means. Remember from before that 0.80s plus 0.10d was the number of sane that we had after transition, and that 0.20s plus 0.90d was the number of demented. Here they are again. Okay, we had the s minus 0.20s plus 0.10d. It gave us the 0.80s plus 0.10d, identical to what we have here. And we got the 0.90d plus the 0.20s. The d minus the 10% that we lose plus the 20% of the same gives us this expression, and that's just what we have here. We call this matrix the transition matrix. If we multiply this transition matrix by this column vector consisting of the populations of sane and demented, then we get the sane and demented after transition, the numbers of sane and demented after a transition. Now we could repeat the process. We could take this number, the number of sane and demented after one transition, and multiply it by the 0.80, 0.10, 0.20, 0.90 transition matrix. Okay, and that's what we've done here. We've taken this result, put it here, and we multiply it by the matrix. When we do this multiplication, we'll get the number of sane and demented after two transitions. Okay, so how do we multiply this? Well, 0.80, 0.10 times this column vector means 0.80 times the first plus 0.10 times the second. And that's just what we have over here on the right. And this might get just a little bit small. Stay as close to it as we can. Okay, we have the 0.80 times the 0.80s plus the 0.10d plus the 0.10 multiplied by the 0.20s plus 0.90d, and that shows up here. And then we have the 0.20 times the 0.80s plus 0.10d, that's here, and the 0.90 times the 0.20s plus 0.90d, which comes out here. And of course these are added. So that this is the result of applying the transition twice to the original populations S and D. Our sane population will be this number. Our demented population will be this number. We can simplify a little bit. I'm not going to go through all the details of the simplification, but 0.80 times 0.80s gives us a 0.80 squared s. 0.80 times 0.10d gives us our 0.80 times 0.10d, of course. If we move over a little bit, the 0.10 times the 0.20s comes up here, and the 0.10 times the 0.90d comes in here. And you should look at your printout and see how these numbers all come from the second row here. When we add all these together, we end up with just 0.66s plus 0.17d and 0.34s plus 0.83d. Okay? 0.80 squared is a 0.64. That's in front of s. And then we have a 0.02 in front of s. 0.64s and 0.02s give us our 0.66s, and 0.80 times 0.10 is 0.08 times d. 0.10 times 0.9 is 0.09 times d. That adds up to 0.17 times d. And we can take the second row and see that it adds up to this.